In this project, we did catchy simulator, and this project was done by myself, Mohammad Ghani, Mohammad Sultan, and Sabarish. Here we implemented it for 1-way, 4-way, and 8-way associative. Here the input, whatever we are going to pass through the arguments. So you can find the example here. The catchy simulator .py is the Python file name, and the din file is the input file we are going to pass. We need to pass the input file name, and the catchy config is like a configuration type for the type 1, type 2, type 3, type 4 catches. So this will be explained later, and this is for the examples for type 1, type 2, type 3, type 4. So this is how you need to pass that arguments in a terminal to print the output. So here you can see the config file.ini. Here the type 1, type 2, type 3, type 4 was mentioned, and it was like block size and catchy size, which is multiplied by 1024 bytes. So the next one is log file. In this log file, we are going to trace all the catchy hit and miss and the output. What we did is, like, from the print tracing statements, we written it on a text file where it will keep all the traces and misses. So the test cases achieved are like 4 test cases, 1, 2, 3, 4, the text files, and the input statements required for the models. Let me go to the main function now.
Yeah, can you start the program? Yeah.
Okay. This is how we need to run the program. Here the catchy simulation started. Here is the main function. So from here we took the arguments as I discussed earlier. See here the arguments has been passing. The first argument is a din file, and the second argument is a catchy config, and the logging to log the traces in the file log text. He will trace all the logs with the time, and the message we will print in the info. So when opening the file to write the output, we are just calculating the time, how much it takes to print to do the simulation. So here the catchy simulator 148-way method I've written. So here the number of ways, it's like 1-way, 4-way, 8-way, that's direct mapped, 4-way associative, and 8-way. Here the config object it to get the input from the config file ini, and the number of way, it should be iterate 3 times for this. Here the type has been get from the config file ini. For example, if I'm passing here type 1, it will read the block size and catchy size from here. So that will come to the size of block and size of catchy, and we are just initializing everything to the catchy initialize. Here we are just taking everything to keep iterating the things and print outside the function. We are just initializing everything here and making a progress from here. So here the size of block, size of catchy, and the way of doing it, and catchy block number, it was like size of catchy by size of block, and this was stored here. And the way it was the set number, how many sets it's going to process. So again we are iterating the hit count and miss count. We are just keeping the track here, and the block placement and replacement also being here. And to move further, we are just printing like this is do with the 1-way associative, and the logging also be done here. This is how the logging has been done. So this will trace all the information in the log.txt. So next the function has been done. It will come out of the loop and go here for the next things like simulation catchy initial is done. Then we are going to do the data frame. Here what we did is, like, we are getting that input file here. The input file has 3 attribute, 3 features. We already know access type, address, and size of data. We need an address to do the thing, so we are taking that data frame address only here and put it as a list here in the line number 157, and we are making the memory reference for that. And then access type, value count, this is to print the how much instructions write was written, the read write instruction. So after converting the length of address, we are changing into the decimal, and the simulation part will continue. From here Sabresh will take over.
So let me run this program for type 2 catch. So I think
from the line
167. so so basically the catch tracing, it, if you see this log file, it will be easy for you to understand. So the input file, for example, right now we are running this 85.gen.tsc. yeah. So here it's two means fetch instruction, and 0 means read, and 1 means write. So the main goal is this address. So we are just taking care of these only this address, and with this address we are finding the tag and index bit, and placing that index bit inside a catch, and whenever there is a new tag comes, we are just placing it based on a least recently used policy algorithm. So if we go through this, so tracing, like miss, when the miss will occur is when the index block is not present inside the catch, when it enters the first time. So in that time it's called as a catch miss. So there is one possible condition, and the next step we need to check where the miss will occur is index block will be the same, but the different tag value will be present. So the requested tag will have some different value, but index tag will be having some other different value. So in this case it's catch miss. So if it is not that, it's a catch hit. The same thing is going for all the cases. It can from for a one way, for one way, for four way, for 8 way. One way is also called as a direct map catch, and 4 way and 8 way set associative catch. So if we go there, like so the least recently used policy
run for the type 3 to
okay. So and I'm just placing, whenever there is a new block enters inside the catch, I'm just placing as a block placements, and I'm incrementing the counter. So whenever I need to go for a LRE catches, when the set is full, so there is no place to fit a new tag inside that respective index. So in that case we need to go for a replacing the block. In direct map catch we are not following any like LRU policies. We are just updating the old values and replacing the new values if it is not present in the catch. So let me move to the output, the result.txt. So this file is always, once you started this simulator, it is in append mode. So you can try different type of combination. Even you can try different types of files and different type of catch sizes to ensure like how the catches and associativity maps. So if you go here, like if you see here this number of block placement, since it is a one-way set associative, it's a direct map catch. You see here the block placement is just 1024, but if you see the replacement it's like a 71,080. So since direct map catch, there is just one set we have, so there is no whenever the new tag comes, we need to replace. That's why you can see the huge difference between the placement and replacement blocks. So and also you can notice here like the cache miss ratio. For this it's like a 7.21%. If you go down, it's like 3.32%. So this is a first one way associative, this is a 4 way. If you go to the 8 way associative, it's 8, I mean it's 2.79. Can you notice the difference between the, I mean the one way and four way? When we are increasing the number of ways, the catch miss decreases, but after certain, I mean certain, like a certain way. So if you see, like after four-way set associative, it is not, I mean it is not decreasing that much. There is like minute improvement by increasing this 8-way associative. This is how the catch principle works, I guess. So that's what my overall conclusion of this project.
And
as
for the
well.
type 4?
Okay.
So go ahead to the LRE cache and finish that
Yeah,
empty
yeah.
statements.
So in LRE cache we are using some for counting purpose. We are for tracing the which block we are using some set count to 0 and 1 to keep track of which block we are placing in and out. That's why that way we are just calculating the hit and miss over here. So if we go down like this, so these are the helper function which is called inside this tracing block to find whether the block is already present inside, whether for the respective index block. For example, if the 2 is 2, if in the index blocks 2 is requested, it need to check whether the 2 is filled or it is is empty. If it is empty, we need to bring that inside the cache. For that purpose I just wrote this helper function. Yeah, that's it. That's the whole tracing.
Yeah,
And
come to the print statements and finish it.
yeah, the print statement is what we are calculating as per the
Handout given.
yeah, I think this is not the handout. Yeah, so this is the handout given. So the print statement here looks like the memory trace and the cache miss ratio. So we follow the same thing and we try to make it here like this. So if you see here the catch simulator results, we are printing the block size, catch block size and catch size, and the number of memory write events happen, and the block placements, and total number of block replacements, and total number of hits misses. And we are also calculating the final goal of our project, a cache miss ratio, using this formula 1 minus hit ratio. The hit ratio is number of hits divided by the total number of references. Here I'm using the data frame, so I'm just giving I'm from the data frame. Yeah, that's it.
And the simulation is done.
Yeah,
Thank you.
yeah, almost done. So if you see, almost done for almost 12 cases is done. Yeah, thank you. Yeah, can you stop recording?
Yeah.